So this is a position time graph, and we're going to figure out whether the x, the position, the velocity, and the acceleration is either positive, negative, or zero. Okay. Now the position is super easy, right? This is positive x. This is a graph of position, right? So if we can read a graph, we're good, right? This is negative x. Okay. So x is easy, right? Velocity is, if we're doing velocity, anything that's sloped up like that, that's positive velocity, right? Because the slope of this graph is velocity. Okay, so this is the slope, and if it's like that, that's zero, and then if it's like this, it's negative. Okay, so this concept here is slope. Okay, and then the acceleration, there's two ways to do it. On a simple harmonic motion, it's actually pretty simple. Okay, hence the term, right? If you have a positive x, that means you've got a negative acceleration. And the reason for this is that the acceleration is just opposite of some constant, the omega squared, that doesn't change, right, times x, right? So it's always just the opposite of x, okay? So if you have a negative x, then you have a positive a. So you could even just label this. This is a whoops, this is negative acceleration, this whole, right? Zero is right there, right? Okay, and then this is going to be positive acceleration. And the reason for that is that, remember, there's a force acting toward equilibrium, okay? So here, anything below here, the force is acting toward equilibrium, which would be positive, would be that way. Okay, anywhere here, if your x is there, you're accelerating toward zero, and therefore you'd be accelerating down or negatively. Okay. Another way to do acceleration, and this works on any position time graph, so it's a more powerful concept, is to look at concavity. Okay. So for example, there's if it's a positively concave, and these are all positively concave, like that. Basically, x is the function. Velocity is the first derivative of the function, and the acceleration is the second derivative. So think about this, right? If velocity is slope, think about what's happening to the slope here, right? It's big negative, and then it goes to zero. That's a positive change. Here it's negative, and it goes to positive. That's positive. That's a positive acceleration, right? Here it's zero, and it goes to positive. Those are all positive changes, right? By the way, these ones smile at you. Okay, and then so these are all positive accelerations. This is another way to do it. This works on any position time graph, so it's a very powerful concept. And the reason it's called positive concavity is that this is like a cave, and we get to it from above. Well, that's not the reason, but that's one way to figure it out, right? Okay, and then negatively concave is like this, or like this, or like this. Okay, and by the way, we get to the cave from below. Okay, this is negative acceleration. Notice that here the slope is very positive and it goes to zero. That's a negative change. Here we have positive goes to negative. That's a negative change. Here we have a slope that goes from zero to negative. Again, a negative change. Okay, so that'll be our strategy here. So let's go through. Let's look at 2.4 seconds. Let's find that 2.4. Well, that's a special one. Okay, that's right there. Okay. So definitely our x is positive. It's either negatively concave or it's accelerating toward the origin. So that guy's negative. Okay, and then our velocity, what's our slope there? Well, I think the tangent line right there would be like this guy. It's a zero slope. Okay. Let's find 7.2. Here's 7.2. That's another special one, right? So our x now is negative. I believe our velocity at that point, that's a tangent line, would be level, right? So it'd have zero slope. And then, of course, we're going to have a positive acceleration. So whenever you're filling this out, right, the acceleration will always be just opposite what that is because of maths, because of physics. All right, let's see. Where's 1.6, 1.2, 1.4.6? There. That's a special case too, right? We're going right through the origin. So x is zero. which is therefore the acceleration is 0, right? Because any constant times 0 is 0. Okay, let's see. Our velocity, is that a I think that's this is, by the way, a maximum. We don't need to but it's definitely a positive number, right? So 0 position, 0 acceleration, but maximum velocity. Okay, 3 seconds. Whoops, 3 is here. Okay, so that is right there. Okay, so our x is positive. So therefore our acceleration is negative. It's also downwardly concave, right? It goes from 0, it's going toward a maximum negative value. So that's also why, right? Okay, I think our velocity is negative there, right? Because it's a downward slope. This line, the tangent line, is sloped downward. Okay, let's find 7.2, 0.4, 0.6. Let's find that guy. 7.6. It's that little chunk right there. Okay, so our x is definitely negative. So therefore our acceleration is positive. This is, by the way, goes from 0 and it's turning into a positive number. It's getting to be a bigger positive number. The slope is, right? Okay. And then our velocity here, that's a positive velocity. It's right there. Okay, let's go 6.2, 0.4, 6.5 is right here. Okay, our x is negative. Our velocity is negative, right? Because that's the slope of this guy, right? The slope is negative there. And our x position is negative. And then because x is negative, the acceleration will be positive. All right. Yeah. All right, let's see. 5 seconds. All right, let's see. 5 seconds. Okay, so our slope is definitely positive there. Okay. Our position is also above 0. Therefore, our acceleration is toward equilibrium, and so we're accelerating downward, right? It's a negative acceleration. Okay, let's see, 3.2. That's a special situation. Let's go right where it goes through 0, right? So our x is 0. Our velocity is, it looks like it's a maximum negative, right? And our acceleration would also still be 0. Okay, so let's just double check, right? Our acceleration and velocity, or acceleration in x should always be in different directions. So that's different. That's a different direction. If they're 0, they're both 0, right? That's different, that's different, that's different. And that's different, right? Okay. Whenever x is 0, the acceleration should be 0, so that's true. Okay. And then let's see, let's look at this guy. 2.4. Yeah, I think we're good. I'm going to go with that.